Okay, so this is going to be part 2 of my recording, and it's only a couple of questions here that I'm going to record because it's a very short section. So this is an example. This is actually example 4 in your book, and it has to do with using synthetic division. I don't know if you remember this. But synthetic division is actually, I think, easier than long division for most students anyway. That's been my observation. I think they're both easy personally, but I've noticed that most students, once I show them this, they're like, oh, this is cake. So this is your question. So we're going to divide 5x cubed plus 6x plus 8 by x plus 2. Okay, so first things first, what we want to consider is we're still missing that x squared here, so we are going to fill this in. So this looks like 5x cubed plus 0x squared plus 6x to the 1, obviously, plus 8. And believe it or not, there's an x to the 0 here in theory. We don't write it, we talk about it, but it is there. Now, since this is x plus 2, we're going to use x minus negative 2. And so this is going to be the number we're actually going to divide by. And so how synthetic division works is we basically put the negative 2 here, and we draw an upside down division bar, right? And so we fill this in with each of these coefficients. So we start with the 5, space it out, then the 0, then the 6, and then the 8. You always finish it off with the x to the 0 power, right? So 5, 0, 6, 8 divided by negative 2. So the first thing we do, step 1, is drop the 5, and then we multiply, literally. Multiply negative 2 times 5, which is going to give you negative 10. Okay? We literally add going down. So this leaves me with negative 10, obviously, because 0 plus negative 10 is negative 10. And we repeat, we multiply. So this is all multiplication down here. This is all going to be addition here. So that's going to give you a positive 20. You bring it over here. And again, we add going down. So this gives me 26. If I multiply again, remember this is all multiplication at this point, we're going to multiply, and this gives me 52, negative 52. Alright, and now at this point I want you to always consider this last column the remainder column. And when we add the 52, negative 52, and the 8, our answer, or our remainder, remember this is the remainder column, is going to be negative 44. So that is the division, and when we collapse this to actually show the answer, we would say that the answer now is 5x to the second power minus 10x plus 26 minus our remainder of 44 over x plus 2. So this is the remainder portion. Alright, for the sake of example, I'll do a second one in case you need it. If not, you can always fast forward the video. So let's do another one. So we're going to divide x to the third minus 7x minus 6 by x plus 2. So same thing applies. Because it's an x plus 2, we're actually going to say we're going to divide by x minus negative 2. And so we put negative 2 here. Okay, remember this is a 1. The x squared is missing, so remember we're going to write this as 1x cubed plus 0x squared minus 7x minus 6. Remember, this is x to the 0, this is x to the 1. We don't usually write the x to the 0, just remember that it is there. So we spread this across using the coefficients, so 1, 0, negative 7, negative 6, and we begin the process by dropping the 1. Remember, this is all multiplication, so you multiply, you bring it up here. So negative 2 times 1, negative 2, so here's negative 2. Again, repeat the process, multiply, this gives you positive 4, this is negative 3. Repeat the process, multiply negative 2 times negative 3, you get positive 6, leaving you a 0. So your final answer will be, in this case, x squared, because this is a 1, right? So 1x squared, minus 2x minus 3, and there is no remainder, so that's your answer. Okay, now, where you do need to pay attention is this next example and concept. This is on the SAT, and you're going to see this. This is called the remainder theorem. And the notation looks hideous, but this is actually a very easy concept once you see it in practice. So the remainder theorem says if I have f of x equal to, this is the dividend, okay, and this is equal to x minus c, which is your divisor, times the q of x, which is our quotient, plus the remainder. So this is your quotient, and this is your remainder. Okay, so yeah, it looks like a lot of gobbledygook, right? So if the polynomial, and I'll show you an example immediately following this. That would be a no meal. Alright, here we go. If the polynomial f of x is divided by x minus c, then the remainder is f of c. Alright, so let me show you what it looks like in practice, and this will definitely clarify this. And then following this, example 6 is the factor theorem, very easy as well. Alright, so this is example 5. In example 5, it says use the remainder theorem to evaluate a polynomial function. Alright, so we have f of x is equal to x cubed minus 4x squared plus 5x plus 3, and we want to use f of 2. Instead of f of x, we're going to use f of 2. Alright, and so since they gave us the 2, and I'm going to highlight it in orange, notice that when I use synthetic division, I'm actually going to divide 1, negative 4, 5, and 3. So that's these guys, the 1, the negative 4, the positive 5, the positive 3, by that 2. Okay, and so when we do that, we drop the 1, multiply, 1 times 2 is 2, so this leaves me negative 2. Multiply, this gives you negative 4, leaving you a 1. Multiply again, and this puts me at 2, so I have a 5 remaining. So I want you to make the connection between that and f of 2. F of 2 means that I'm going to have 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. When I do that and I do the math, I end up with 5. So notice that these are both identical. And that is the concept behind the remainder theorem. If you wish to try one on your own, I'll give you a try question to do and the answer. Follow the example above. I promise you it'll be identical. So this one says given f of x is equal to 3x cubed plus 4x squared, minus 5x plus 3, use the remainder theorem to find, and we want to find f of negative 4. When you do this, your answer should be negative 105. Okay? So let's talk about example 6. Example 6 is the factor theorem. That's the last example that I have for you today. And so in this case, the factor theorem. Okay, so in this case, let f of x be a polynomial. So if f of c is equal to 0, then in this case, and this is the question they always ask on the SAT, notice that this is c and this is x minus c, is a factor, of f of x. Okay, the second concept in here, if x minus c is a factor, then f of c is equal to 0. So that's what we solve for the factors. So like if you have an x minus 2, x minus 3, then your solutions sit in there as well as the opposite sign, right? And so here's example 6 that falls right upon that. And so it says solve the equation given 2x cubed minus 3x squared minus 11x plus 6 equal to 0. Okay, given, so they're giving you a factor, given that 3 is a 0 of a 0 of f of x is equal to 2x cubed, blah blah blah, the same thing. Okay, so if that's the case, then since they're giving you 3, you're going to use the 3. This is in synthetic division, what they're telling you, if I'm going to use synthetic division, and this is kind of like a connection between the two, is that you're going to use the 3 out here, and yes, we're going to use the coefficients 2, negative 3, negative 11, and 6, which are given to you in the polynomial equation. We drop the 2, we multiply, obviously that gives us 6. When we add, we end up with 3. 3 times 3, well, that gives us 9. That leaves us with negative 2. And 3 times negative 2, that's negative 6. So I have no remainder. Remember, this is always the remainder. And so we end up with 2x squared minus 3x minus 2. And that's our answer, since our remainder is 0. If I'm using long division, and they give me this question, then I'm dividing by x minus 3. And this divides into the full Monty, which will be the 2x cubed minus the 3x squared minus 11x and then plus 6. So if I were to divide this, obviously this would become 2x squared plus 3x minus 2, and this is the result of, obviously doing the math. So what this is saying is that if I take x minus 3 times 2x squared plus 3x minus 2 after doing long division, because remember there's steps in here. There's steps. I just gave you the result to save time, okay? So this would be the equivalent of 2x cubed minus 3x squared minus 11x plus 6. Okay, and so that's remainder theorem. What happens here is that if I know that I broke this down to this value here, then I can actually continue, because I can actually factor that out. So let's continue this. Since I already know that 3 is one of my solutions, I've already simplified the process, right? And so let me go ahead further so I can show you the connection. So now we're going to focus here on the 2x squared. We're focusing right here, 2x squared. Alright, and then this factors further. This can be factored as 2x times x. I could do a -1 and a +2, and so this is the factorial, the 3 factors of this. So my solutions are 3, positive 1 over 2, and negative 2. So that's the solution set. Okay, now I am going to try and see if I can get back on the internet at some point. Obviously, if you get these videos, I had a momentary opening that I was able to upload them. So please use them and continue in Pearson as you are able. Because this is a city outage, so apparently it's the area where I am. I'm in the Taft hiatus area, so you know, I'm trying my best to get back on. Believe me, this is agitating, and certainly a stress none of us deserve. So anyway, let me stop the video and go on a rant here. Let's go back.